Okay, so before the break, I started to explain flip-flops. Flip-flops are actually one of the very important logic circuits. Usually we use it all the time. So as I told you before, a flip-flop is a storage unit. It's a logic circuit. Logic circuit. This logic circuit is actually a storage unit that can store 1 bit. So every flip-flop can store 1 bit. That's why you will see later. If I want to make like something we call a register. A register can store, for example, 8 bits or 16 bits. In case of a register, if I want to store 8 bits, I need 8 flip-flops because every one flip-flop can store only 1 bit. Okay. One of the most important things also, flip-flops are synchronized because this is the main difference between flip-flops and latches. Latches also, a storage unit can store 1 bit, but they are not synchronized. This is the main difference. So what do you mean by synchronized? In latches, once you change the input, the stored value is going to change immediately. Okay, that's why we call it, it's not synchronized. This one's synchronized, that means, as I said before, they have what we call a clock. They have an input for a clock. Okay. If the block of the flip-flop has like a triangle this way, that means this is a positive edge. But if there is a bubble this way, that means it is a negative edge. Okay, so what do you mean by synchronous? That means we can only change the stored value only at specific moments here. That's right. So the stored value cannot change here. Stored value can change here or here or here. So if I change the output here, I have to wait until the first rising edge to change the value. Okay, so that's why you call it synchronization, because it's a specific time. Okay, and usually in logic circuits, we like something like that, especially if you have a big system. We need synchronization. We need to have some control about when we can get the output. And usually what happens, we use the whole system is using only the same clock. So only one clock for the whole system. Okay. Anyway, so here, in case of, if you see, if it's just a triangle this way, that means it's a positive edge. That means the stored bit can only change at this moment at rising edge. But if I put a bubble this way, so you can tell from here that this is a negative edge. That means the stored bit can only change, it changes at falling edges. Is that okay, guys? Any questions? Good. And then after that, I told you I will teach 3 types of flip-flops. Okay. One is called D flip-flop, T flip-flop, and GK flip-flop. Okay. You need to know them very well because we are going to use them in this chapter and next chapter as well. Okay. And as I told you, there will be a quiz on Thursday. This quiz is gonna cover these flip-flops. I want to make sure you understand how they work. Okay. So let's see. The first one here, I told it last time. This one is called G flip-flop. So as you see here in G flip-flop, it has only one input. We call it G, one input. We have Q, usually we have Q and we have Q prime. Is that okay? So Q is a stored value. Q prime is the opposite. So it's a complement of Q. Okay? So here you have 2 outputs. You will not use both of them, but I give you the option. I give you the stored value and the complement of it. So it doesn't mean I need to use both of them all the time. No, it doesn't mean that. Okay. So here, this is the stored value here in Q, and this is the complement of the stored value. It depends on your design. Sometimes I need the stored value, sometimes I need the complement of the. So you have both. Okay. You can. It doesn't mean you need both of them all the time, but this circuit or the flip-flopping gives you both. Also, we need to have a block, as I told you before. Okay. First of all, for each one of them, for each flip-flop, you need to know how it works. So now, because I have only one input, which is D, this input can have only 0 or 1. Okay. So if D is equal to 0, Q is equal to 0 at the first rising edge. Is that okay? If D is equal to 1, Q is equal to 1. That's very easy. That means if I want to store 0, I'm going to put 0 in G. That's it. And then at the first rising edge, it's gonna store 0. Okay? If I want to store 1, I'm going to put here in 1. I'm going to put in G here 1. Okay? I'm going to put it 5 volt. Okay? And then at the first rising edge, I will find 1 here. That's it. Very easy. Any questions? So for each one of them, you need to know how it works. Also, you need to know what we call characteristic equation. Very important, this characteristic equation, because we will use it. The characteristic equation gives you the relation between the output and the input. Okay? So here I'm going to use T plus 1 and T. So what is the difference? T plus 1, that means this is at the rising edge. Okay? This is the new value for Q. D of T, this one means before the rising edge comes. Okay? So that means you can tell from here when G is equal to 0, Q is equal to 0. When G is equal to 1, Q is equal to 1. That means the new value for Q should equal the current value for G. Okay? This is before the clock, this is after the clock. Okay? Any questions? Q is equal to G. But you need to know this is the new value for Q, and this is the current value for T or before the clock. Okay? Any questions? We have another one here I'm going to teach. Okay? Here, I just give you like summary or overview for the three flip-flops. I finished the first one in details, but I will explain the second one in details, and the third one is with J, K, and T. The second one here, we call it T flip-flop. Look here, it is exactly the same thing. Look here, it's exactly the same thing. We have Q here and Q here, Q prime, Q prime. We have here one input and one input. But the difference is, this input, we call it T. This input, we call it T flip-flop. Okay? Let's see how it works. But for sure, the way it works is different. Okay? Here, if T is equal to 0, Q is 0. If T is equal to 1, Q is 1. Look how this one works. Here, if T is equal to 0, no change to Q. If T is equal to 1, Q toggle. Okay? So this one can do one of two things, either no change or toggle. Toggle means complement. Okay? So this is the two things you have. Either no change to the stored value, or you want to complement the stored value. Okay? This is very useful in case of counters. As I'm going to explain later, one of the very important logic circuit is counter. If I need to count, there are some circuit to count. So this is usually used in this circuit. It can be used for many other things, but this is how it works. Okay? Now, what is the characteristic equation, which is the relation between output and input? Okay? Q at time T plus 1, you need to know this characteristic equation because we will use it shortly. I think today we will use it. So this one is equal actually T at time T exclusive or with the old Q. Okay? Q at time T. So the new value for Q is actually equal exclusive for T and Q. Okay? And if you look here, this characteristic equation can actually confirm how it works. For example, here, if T is equal to 0, you know, as I told before, I just want to review you guys. If you have 0 and X, what is the output in case of exclusive or can anyone remember? Same thing, if you have 1 here, one input is 1 and one is X. For the first one here, 0x. For exclusive or, what is the output? It's X. It doesn't change it. Okay? For any value, whatever the value is, you can write it. X is 0 or 1. But if you have here 1, actually you will get X prime. Okay? Based on how exclusive or works, you can see, you can get this one here. So if T is equal to 0, so that means whatever you have here, it will be the new Q. Okay? But if T is equal to 1, so actually what we get here is going to be Q prime. Okay? So that's why it's a toggle. Any questions? I will give you more details about T flip-flop, but this is like a big picture. Okay? One more thing. GK flip-flop. Okay, this is the third one. In case of GK flip-flop, as you see here, still we have Q and Q prime, and we have clock. Okay, these are the basic inputs and outputs. But here in this case, we have two inputs instead of one input. We have two inputs. One input we call it J, and one input we call it K. Is that okay? Tell me how it works. Very simple. Number one, 0, 0, no change. So the two inputs 0, 0, no change to the stored value. So when a clock comes, no change. Okay? Very easy. When it is 1, 1, so actually toggle. 1, 1 is toggle. Okay? If it is 1, 0, so if J is 1 and K is 0, we actually are going to make a set. Okay? If K is 1 and J is 0, okay, so actually you are going to make reset. So now we have four things we can be done here. Number one, no change. You can toggle, you can set, you can reset. Any questions? Let me ask you a question, because I think this will be in the next week lab, and the coming week lab. So here, if I have a GK flip-flop, let's think about it. We have Q and we have Q prime, and then we have G and we have Q. If I tie the two inputs together this way, this flip-flop becomes. So now I have only one input. I'm gonna tie G and Q together and have one input. Now GK becomes T flip. So GK becomes T. So why? Let's see. If input is 0, so that means G is 0, K is 0, no change. Makes sense? Is that okay? So I will be here. But if I input here 1, that means 1, 1 is gonna toggle. No change and toggle. That's exactly T flip-flop. So if you go here, if you see T flip-flop here, it's either no change or toggle. You got what I'm saying? I think this will be a question in the coming lab. So if you have GK flip-flop and you wanna turn it into a T flip-flop, you can just tie the two inputs together. Okay. The last thing I want to show here, and this should be important, is a characteristic equation. The characteristic equation is the new value for Q equals the current value for G, okay, and U prime, okay, or Q prime and U. Okay, maybe this one a little bit bigger than the other ones. I will prove it to you. So in the slides, I will prove to you, given 0, 0. So given, I can show it to you right now. For example, if you have here 0 and 0, okay? So now this is A, so this one becomes 0. Makes sense? But here, because this is prime, so this one becomes 1 and Q, so I will get the new value for Q equals the old value for Q, which is no change. I just want to show you, I want to prove that this equation is going to do the same thing on the table here. Is that okay? Let's see if this is the first one. Let's do the second one. If it is 1, 1. So if it is 1, 1, so this is because I have a prime here. This one becomes 0. Okay? And this one, and because this one is 0 and this is end, this term also becomes 0. Here we have 1 and Q prime. You know, if you have 1 and X, I get X. That's why here the new value for Q is going to equal to Q prime, which is 2. You get what I'm saying? You can try the other ones, you will get the same result. I just want to prove to you that this equation is going to give this table for us. So for example, if you put here 1, and you put here 1 and 0, and you put here 0, okay? So here 1 and Q prime is Q prime, so this one becomes, this one here becomes Q prime or Q. You know Q prime or Q is equal to 1. That's why if G is equal to 1, K is equal to 0, I'm gonna get 1. I'm just proving it, okay? I just plug in these values. So so that is it here. Let's try the next one here. If I make it 0 and 1, okay? So if I make it 0, so this one is 0, so this term, the whole term here is 0, because you know in case of N, if one input is 0, regardless of the other inputs, output is 0. Okay? Same thing here because K is 1, so K prime is 0. 0, 0, and anything also 0. So the result here is 0. That's why it is reset. Okay? I'm just proving it. Any questions? So again, let me summarize what I said. I will give you more details now, but let me summarize what I said. Number one, you need to know we have 3 flip-flops. For every flip-flop, you need to know how it works. So you need to know when you for different values of inputs, how the Q it changes. Okay. Also, you need to know the characteristic equation because we will use it. Okay, for the 3 terms. Any question? Okay. So here I started with the flip-flop last time. I explained how we can make it. The way we designed it using GLH as I explained last time. So this is how it looks like inside. So inside the block here, this is how it looks like. That's what I explained last time. Here I'm explaining how it works. Okay. Only action, I'm repeating it, only action is taken at certain times. Okay. And so in the middle here, even look here, look, the changes here. The changes here, but no change here. Because we only change the value of Q at this specific time. So even if you change it in the middle, nothing will be shown here. Okay. This is different from ledge. If this is a ledge, I would see something like that. Once you change it here, okay. So once you change here at this moment here, this one has to go to 0, and then once you change here, so this one has to go to up because in case of a ledge, once you change the D value, your value changes immediately. Okay, but here no, it has to change only. So I don't care about what happens here. Just at the clock, I will see what is the value here, and the same value will go to Q. Okay? Any questions? You have another example here, and then here I'm explaining positive H. You can just by very small difference between the design. So here, if I put the inverter this way, it becomes negative H. Okay, but if I move it here. Remove it, just a very small change, I can make it positive H. Okay? And not only that, if you already have a chip, because that's what we will do next week, you have a chip, this chip has a big flip-flops, okay, inside the chip. So even if you have a flip-flop already, for example, positive H, you can easily make it negative H. All what you have to do is just put inverter here. So if you have a flip-flop that's negative H, it's easy to make it positive H. If positive H, it's easy to make it negative H, right? Don't add inverter. Okay? Anyway. Yeah. One more thing I told you, sometimes for flip-flops we add more inputs. Okay, so you can for next week you can see the data sheet. You can see what inputs you have. I explained the basic inputs. Basic inputs are Q prime, Q, clock, and D flip-flop. D. But sometimes we have other inputs. For example, here we have one input we call it clear. We have one input here we call it preset. So here preset and clear. Okay. So these two inputs, sometimes you don't have it. You don't have them. You got them saying. So it's like a design. So sometimes when you buy a chip, you can find these inputs or you may not find them. Okay. It depends on for sure on the chip. But what is the purpose? Number one, what these inputs are doing, and what is the purpose of these inputs? I'm going to tell you. Number one, here you can tell from the English name clear. So this one here, and you know bubble. Once you see a bubble here, that means this one is active low. Okay? That means if I put here 0, I'm gonna clear it. I'm gonna put 0. I'm gonna clear it. Okay. For this one here, if I put 0 here, but I have to make sure this one. So the way you have to use it, guys, either you put here 0 or you put and if you put here 0, you have to put here 1. Okay. And if you do that, you are gonna clear it. You're gonna put 0. Okay. But if I put here 1, I put here 0. So actually here you are gonna set. So you are gonna store 1. So I have two inputs to store 0 or 1. Someone can ask me, but wait a second. So D is known that D can store 0 or 1. So what is the difference between D and these two inputs? Big difference. Okay? D is used in the normal operation. Normal operation, you have to use D. Okay? Sometimes, especially if you want to do initialization in the very beginning, sometimes I want to clear immediately, like an H, immediately. Don't wait for a clock. Okay? So here, once I put 0 here, I'm not going to wait for a clock. Immediately, it's going to be clear. Okay? Sometimes I want to set immediately without waiting for the clock. So these are not the normal operation for the flip-flop, just used for initialization. If you want to initialize it, and the main difference between these two and G, this input is a normal operation. This one is synchronized. It has to work at each. These two inputs are going to happen immediately, okay? Just before initialization. And in the coming quiz, I will ask about this one here. So the coming quiz, as I told you in my email, it will be very similar. It will be similar to this slide, okay? I just will change, it's exactly the same thing, but I will change the signal, but it will be exactly the same thing here. So if you look here, so now here, guys, we have three types. We have three types of operation. Either 0 here and 1 here, and this is clear, okay? Or 1 here and 0 here, this is sticky, okay? This is not the normal operation. Or 1 and 1. If it is 1 and 1, so now it's a normal operation. Okay? Normal means now if D is equal to 1 at the first stage, I'm going to store 1. If D is equal to 0 at the first stage, you store 0. You got what I'm saying? So here, so the way, so the question will be similar to this one, similar to this slide here. The way you have to think about it is, number one, you have to look at, you have to know where are we here? Is that, are we in clear mode? Are we in sync mode, or we are in normal operation mode? You have to decide, okay? So if you look here, in the beginning here, this is clear. You can see the clear is 0, set is 1. So this is not the normal operation. This is clear operation. We are in clear mode. Okay? So don't look at G. I don't need to look at G. I don't even need to look at the clock. Because this clear is going to happen immediately. Regardless what is D, regardless what is the clock. Okay? So that's why you can see here, the output here at this moment. Okay, the output here is 0. Is that okay? So once you see 0 and 1, this is not the normal operation, this is clear operation. In clear operation, I don't care what is the value of G. I don't care what if there is a clock or not, because this happens immediately. This is, we are in clear mode. Is that okay? Okay. Now let's look what happens after that. What happens after that here in this period here? Let's see the different color. I like this one. So if you see here, guys, from here to here, this one is 1, and this one here is 1. 1 and 1. So this is what? This is a normal operation. 1 and 1. So now it's a normal operation, because it's normal operation in this period here, it's a normal operation, because it's normal operation. So here it changes only, it's going to happen at the clock. Okay. So that's why you see this one was 0. It's going to continue 0 until clock happens. At the clock here, D is 1. So here Q should be 1. That okay? So if you see here, Q was 1 here, okay, but there was no clock. Okay, so it's a change will happen only at the clock here. Okay. This here also is still here in the normal operation. If you see here 1 and 1, it's a normal operation. In the clock here, look here, D now becomes 0, but no change here. Because again, Q value, it changes, okay, when clock comes at the clock. Okay, so here at this time here, this one has to become 0, equal to G. Okay, let's see what happens after that. What happens after that? If you look at the period here, this time period here, guys. Yeah, this time period here. See, so here is 1, but set is 0. Okay. So again, now we are not in the normal operation. We are in the set. We are in the set mode. Okay. So regardless if there is a clock or not, immediately this one has to come high. Immediately. Okay. After that, we return it to the normal mode. 1 and 1, normal mode. In normal mode, it changes only happens at the clocks, at the edges. So is that okay? And at the edges, Q is equal to D. Very easy. So what happens here? Only at the edge, D was 0. So now this one becomes 0. Okay, guys? So again, I'm very easy. I'm telling you that width will be identical to this one. I will make some changes to the signal. Okay, but it will be similar to this one. Any questions? Go. Also, sometimes we can have enable. Okay, again, this is not a basic. Okay, that's why I maybe it's a flip flop you will use next week. It doesn't have enable. It's not essential. Okay, the essential one is D, Q prime, and the block. Okay, some of them also have some enable. Okay. Now I will go to GK flip flop. How can we make it? I told you in GK flip flop, I already explained how it works. As I told you guys, 0, 0 means no change. If G is 0 and K is 1, this is a receptor. If G is 1, K is 0, this is a sector. 1, 1 means it's a toggle. Okay, that's how it works. Okay, this is the characteristic equation I told you about. Okay, now how can we make it? The way you can make it, okay, the way you can make it, I still can use D flip flop, okay, but I put this part here. This part is actually this equation. So if you see what is the value here, the value here is similar to this one, okay? So here, and then because I know if the value, because of this part here, the part I have here, whatever I have here, the value here at the input of D should equal to this one. So that's why the output, once I have, you know how D flip flop works. In case of D flip flop, Q is equal to D. Okay? So here Q is equal to D at the edge. That's why I'm gonna add this circuit here, okay? And then D flip flop. This is one way to do it, or one of the ways to do it. So now it becomes, this is like one block here. Now it becomes GK flip flop. So this is something inside the Q. Okay, you don't need to add it. You understand what I'm saying? I'm explaining how can you make GK flip flop. So this part here should be inside it here. Okay. Or if you have a T flip flop and you want to turn it into GK flip flop, you need to add this part here. Okay. You need to use a characteristic equation. Okay. And I proved to you, and it's already mentioned here as well. Yeah, it's mentioned here. Why this equation? Using this equation, I'm gonna get this response here. Okay, so you need to plug them in, and that's what I did here. Okay, I don't need to repeat it, but you see here, I put G is 1, K is 0. I just plug it in here, and I find the result is 1. So G is equal to 1, and then I know Q is equal to 1. Okay, because internal here, it has a D flip flop internal here. So if this one is 1, once I put this one becomes 1. I tried another value, 0 and 1 as you see here. I found D is equal to 0. So that means Q is equal to 0. And then I tried 1 and 1. I found D is equal to Q prime. Total. I tried 0 and 0. I found D is equal to Q. Okay. In the coming quiz as well, for GK flip flop, I will give you something like this one. Okay. Again, I'm gonna change the signal G and Q. So what I will do, just to be very clear, I will give you the clock. I'm gonna give you G. I'm gonna give you Q, and then I will ask you to draw Q. Okay. Same thing here. I will give you the clock. I'm gonna give you G. I will give you clear, give you preset, and then I will ask you to draw Q. Okay. I just want to make sure you understand how it works. That's easy. Just you need to study this slide, understand it very well. Same thing, study this one, understand how it works, okay? And Same thing for T flip-flop. So there will be three parts, one for G, one for T flip-flop, one for JK flip-flop, okay? So that's it, you can get full mark if you understand the group, okay? So let's see how it works here. Again, here I'm telling you it's rising age. This is not something you can guess. So I tell you it's rising. That means it changes happens only at these times. So you don't need to worry what happens here in the middle. You don't need to worry about it. Okay, just look at this exact moment. Okay. So if you see here, guys, at this moment here, it is 0 and 0. And you know 0 and 0 is no change. Now we start from Q 0 is gonna continue 0, no change. Okay. Now I don't care about what happens in the middle. I'm gonna look at this moment here. At this moment, now it is 1, 1 and 0. I know when G is 1, you need to memorize the table. It's a very small thing. Okay, and you know when G is 1, G is 0, so it has to be a set. That's why it has to be a set. Okay. Again, I need to look at this moment here. At this moment, it is 1 and 1. 1 and 1. So you know 1 and 1 means toggle. Toggle means this one was 1, now it has to be 0. Okay. After that, I'm gonna look at this moment here. At this moment, it is still 1 and 1. You know 1 and 1 means toggle. Okay, that means this one is 0, should go to high. Okay, again, next I'm gonna look here. Okay, so at this moment you can see it became 0 and 0. 0 and 0. You know 0, 0, no change. So now this one was high, it's gonna continue high, no change. Okay. After that, I'm gonna look at this specific moment. So at this moment, it's still 0 and 0, no change. Something happening here, I don't care about it. We only look at the specific types. So if you look at this moment here, it is 1 and 1. So that means it has to toggle. It has to go to 0. Okay. If you look at the last H here, this is 1 and 1. So it has to toggle. Okay, guys. So suppose will be the second part of the quiz we will have this one. Any questions? Time in diagram like this. I give you another example here. I will leave it to you, okay? So just nothing new. This is just another example. It's exactly the same thing here. So if you see here 0, 0, so no change. And then if you look here 1 and 0, it has to be set. If you look here at this block here, it's 1 and 1 has to be toggle, and so on. Okay, so it's very easy. Okay? Yeah. Also here, nothing is new. What I'm saying here, this one is similar. We can also for GK flow, we can add set and preset as well. Because as I told you, it's something optional. It can come up with set and clear and set. And it's gonna work exactly the same way as before, same way, like G flip-flop. You understand what I'm saying? So now it is 1, 1, this is a normal operation. Now it's going to work as a GK flip-flop, normal GK flip-flop. But if it is 0 here, that's clear. Regardless what is J, what is K, what is clock, we don't care about them. Same thing, okay? One, so also I want to show here, I told you here, in order to create GK flip-flop, I need to make this logic circuit here at the input of G, okay? Yes, you can do it using AND gates and OR gates this way, or another way, you can do it using NAND gates. Nothing is new. If you just see what is the value here, it will be similar to the same equation we had before, just different gates. Okay? So when you go home, you can. I already did it here. So you can see this one is Q prime, this is J, this one is K prime. This input here is coming from here, so this one is Q. So if you calculate what is the value here, it will be similar to this one. Okay. Because as I explained before in this course, if you remember, I told you before, if you have AND and then followed by OR, I can implement this one using NOR. NOR and NOR, if you remember, okay? And that's exactly what I did. So here I did it using, NAND. Here I did it using NAND. It's exactly the same thing here when I have AND and then followed by OR. Okay. So again, nothing new. Any questions? Okay. Same thing for G flip-flop, as I told you here, as I told you, if you have a G flip-flop, you can tie the two inputs together. Now it's gonna act like T flip-flop, as I told you. Okay? This is how T flip-flop looks like. We have only one input T, and this is how it works. Okay? We have only two cases. If the input is zero, zero here means no change. Okay? So here, if you see this table, if the input is zero, no change. What do you mean by no change? I mean, if the current Q is zero, at the clock, it's gonna stay zero, no change. If it is one, at the clock, it's gonna stay one. Okay? But if T is equal to one, that means it's a toggle or complement. That means if the current Q is zero, at the clock, it becomes one. If it is one, at clock, it becomes zero. Okay? Toggle. Number two, how can we design, how we can make it? One way to make it by using G flip-flop, but I'm gonna put here XOR this way. So here, so this is how it should be inside here, inside the block. How can, so you can see here, I was able to create G flip-flop using D flip-flop. Okay, so let me go back here just. So in the very beginning, I explained G flip-flop. Okay. So here, this is D flip-flop. I created D flip-flop using D latch. D latch. This is a latch I explained last time. So from D latch, I created D flip-flop. And then, once I created D flip-flop, I just added this circuit here, and now it becomes G flip-flop. And now, I added this circuit here to the D flip-flop, it became G flip-flop. Okay, so I added here exclusive port here. So here we have Q here. So this one is Q, this one is T. So now T, the input here is actually Q exclusive for T. Okay, so T exclusive for Q. This is T. Okay. And this is the characteristic equation. You need to know the characteristic equation. I will show you this equation. This part here will do the same thing we are expecting here. As I told you, if T is equal to 0, 0 is equal to 4Q, and will get the same Q. So whatever the value here, it will get the same value back. Because that's how it works, okay? The way it works is actually Q is equal to G, because in the D flip-flop, Q is equal to G. And G here is actually T is equal to 4Q. So when G is equal to 0, so this one will be similar to Q. Okay, and because Q is equal to G, there will be no change. Okay. Same thing here. When G is equal to 1, okay, I will get here Q prime. What Q prime, whatever. So here, if it is 1, this one becomes 0. If it is 0, this one becomes 1. Okay, and then because this is D flip-flop, this is a new value I will get. Okay. Again, for every one of them, you need to know number one how it works, which is this. This table here, which can tell how it works. Number two, you need to know the characteristic equation. Okay, let's see, because also in the coming quiz, I will give you also something like this one here. Okay, so here you have rising edges. Here we have only one input T, and we have Q. The initial value for Q is, the initial value is 0. Okay, let's see. I'm gonna look here, I'm gonna look here, I'm gonna look here, only this moment. So then, I'm gonna look at this moment. Very simple. If T is equal to 0, no change. If T is equal to 1, toggle. That's it. That's it. Either toggle or no change. That's it. So you what happens here at this moment, T is equal to 0, so no change. Q, are you 0? Yes, please stay 0. That's it. Listen. Okay. Now, here at this moment, T is 1. Okay, T is 1 means it's a toggle. Okay, that means it has to toggle here. At this moment, T is 1, so it has to toggle again. At this moment, T is 1, so it has to toggle again. Okay, at this moment, it's 0, no change. At this moment, it's 0, no change. That's it. Okay, guys. So this will be the third part in the quiz. So all what you need to study, the 3 slides I told you about. Okay? Any questions? Nothing here new. I just summarize what I did. Okay. Okay, so now what I did so far, guys, I explained 3 types of flip-flops. Okay, now you should know what is flip-flop. You should know, okay? But I want to remind you why I'm explaining flip-flop. This chapter is about sequential circuits. Okay, so why I'm teaching flip-flop? Simply because flip-flops are essential elements in sequential circuits. Okay, so that's why I need first to teach you what is flip-flop, and then after that I will show you how can we use flip-flop to create sequential circuits. Okay? Also, I want to remind you what we have done in this course so far before this chapter. Everything we done in this course. I told you before if chapter make. I want you to remind what I said. So for logic circuits, we have 2 types of logic circuit. Number 1, we have what we call combinational logic circuit, and that's exactly what we have done so far in this course before this chapter. Everything we've done before was combination circuit. Right? So in case of combination circuit, the output, the value of the output depends only on the inputs. That means always, and that's why in the truth table, that's what we did in truth table. So every time you have this input, I will get this out. Every time I have this input, I will get this out. There is no way for the same input, I will get 2 different outputs at 2 different types. There is no way. Always this input, I will get this out. That's why we call combinational circuit. The second type of logic circuit, we call it sequential circuit. And in sequential circuit here, the main difference is the output depends on 2 things, not 1 thing, okay? It depends on the current state, and also the value of the input, okay? That means for the same input, I may get different outputs if in case of 2 different states. You know what I'm saying? So here the output here does not only depend on the input alone, it still depends on the input, but not alone, it also depends on the state, okay? As you understand, but as I'm getting explain more, for example, if I'm state 0 and the input is 1, maybe I'm gonna get 1, okay? But I mean, if I'm state in another state and the input is 1, maybe I'm gonna get 0. You understand what I'm saying? So here, but for sure, for the same state, same input, you will get the same output. Same state, same input, you will get the same output. You know what I'm saying? But here, the output does not only depend on the input, but also depend on what is the state. Okay? I'm sure you will understand better what I mean by state, because the way we do in sequential circuit is different. There are some similarity to what we did in combination circuit, and there are differences. Okay? So, but in sequential circuit, the way I will explain it is usually the system has states. Okay? And this state depends on is somehow it's related to flip-flop. Okay, so if I have only 1 flip-flop, if the circuit has only 1 flip-flop, that means I have 2 states. 2 states which is 0 or 1. So if the flip-flop is 0, this is a state. If the flip-flop is 1, this is the second state. Okay, guys. So the number of states should be equal to or less than or equal to the power of n, where n is the number of flip-flops. Okay, so if you have 2 flip-flops, that means I can have up to 4 states. For example, here 0 0, if the 2 flip-flops are 0 0, it's 1 state. If 0 1 is the second state, 1 1 or 1 0, 4 states. Up to. Why up to? Because maybe I'm not getting this state. Maybe I'm going to only use 3. Okay? Because if you have 3, still I need 2 bits. 2 bits for 3. Because I'm saying 1 bit is not enough. Yes. Okay. So you will understand. So I just want to link between flip-flop and the states. So that's why we are using flip-flops. We are using flip-flops to create states. And now you know the number of states. The number of states should be less than or equal to the power of n. And n is the number of flip-flops. I will give you for sure more details. Okay? Any question here before I give you more details? Don't I didn't explain anything yet here, so don't worry about it. But I just want to make sure you understand what we are doing now is different from what we did before, and you should understand how it is different. but for sure I will in this chapter I will focus on sequential circuits. Okay? So here I'm telling you, sequential circuit can be synchronous or asynchronous. Okay, again, synchronized or not synchronized. Okay. In this chapter, we are going to focus fully in synchronized. Okay, the difference between them, if it is asynchronous, you know, asynchronous is not synchronized. In this case, I'm going to teach. Okay, but we're not going to teach this one. Okay, because usually most of the circuits are synchronized. That's why we will teach flip-flops. So we have, so as you see here, we have flip-flops. Maybe I'm going to use some combination circuit as input to the flip-flop. Okay, we have input. So this is like a diagram for the circuit, sequential circuit. In any sequential circuit, number one, we have flip-flops. That's number one. Number two, sometimes we need to use some combinational circuits here connected to the flip-flop. States are here. States are here as a flip-flop. Okay. And usually there is a feedback between flip-flop and the combination circuit. Also, you can see we have input here and also we have output. Sometimes we get the output from the combination circuit, or sometimes the output we get it from the flip-flop. So you will see all of that, okay? Someone last time, some student asked me about the delay. What is the effect of the delay? For sure, the delay has some effect for sure. So if you have a clock here, and so I told you Q is equal to G. For example, if I'm using G flip-flop, so in case of G flip-flop, Q is equal to G. But this change is not going to happen immediately. That's what you have learned in this course. There is always a delay. And if in many levels, I have to calculate the delay. Okay, that means if the H, if this is the clock and this is the rise in H. Okay, so here Q and we have G. For example, G is 1. G is 1, for example, this way. And now Q was 0. This is Q. It was 0. Do you think Q is gonna become 1 immediately and exactly at this one? The answer is no, because there is a delay. Yes, in some figures, I make it immediately, so to make it easy for us to understand how flip-flop works, because this is my main focus. But in reality, or practically, there will be some delay here. Okay, and as we did in many labs, this delay. So here, yes, this one will be hard, but it's going to take some time because of the delay, not immediate. It's a very short delay, but this is how it is. Okay. And what's really important to understand, because of this delay is going to restrict what frequency I can have for the clock. I can't make the clock very fast, so that the new H comes before this action is taken. You understand? You understand? Do you know that's a very important thing? You should understand what is the relation between the delay. The delay is going to make a restriction on the maximum frequency I can have, because keep in mind, the higher the frequency of the clock, the faster the computation. So that's why when you buy a laptop, when you have 2.4 gigahertz, this one will be faster than 1.4 gigahertz. You know that, right? This is because of the clock. Okay, this is the clock. This is the frequency of the clock. But there is a restriction with that. The restriction is the delay. Okay, because very simple. I have to make sure before a new H comes, I have to make sure this one already done, right? So that's why this delay is going to make a restriction with the frequency. Okay, it's something important you need to understand in this course. Okay? Okay. So what I will do right now, guys, I will do two things. Number one, this is what I will do in this chapter. What I will do in this chapter, I'm going to do two things. Number one, analyze sequential circuit. I will give you a sequential circuit, and then I ask you to analyze. And that's what you will do in the coming lab. In the coming lab, and also that's what I will ask in test two, in test two. So test two, I will give you a circuit. I ask you to just analyze it. Okay. The second thing we will do, design a sequential. This is what I will do in this chapter. So this chapter I will do two tests. Number one, given a logic sequential circuit given to you, can you analyze it? I will tell you what I mean by analysis. Okay. So that's what you will do in the coming lab. Okay. Also, that's what will be in test two. Design. Now I will ask you to design a circuit. Okay, this will be the second part in this chapter, the last part of this chapter. Okay, and this will be in the final exam. Okay, let's start with analyze. What do you mean by analyze? You understand? You will give me a sequential circuit. I will give you a circuit, and then I will ask you to analyze it. Okay, I want to make an analogy here, and I want to make an analogy to combinational circuit. So, in combinational circuit, if I give you a circuit, I just want to. What I'm doing right now, guys, I'm explaining what do you mean by analyze. I give you a circuit and then I ask you to analyze it. What do you mean by analyze? Okay? So here it will be something similar to what we did in combination circuit, but for sure there are differences. I will explain difference, but I just want to make an analogy here. So to tell you this is similar to what we did before, but we need to consider the difference. Okay? What we did before, for example, if I give you a circuit, something, for example, something like this one here, any circuit, we have here X, we have Y, we have here Z, for example, here Y. So if I give you a circuit and you have F, so given a circuit, can you create the truth table? Yes. How can you create the truth table? You have to take X, Y, Z. This is the inputs. You have to put all possible cases as we did before. Is that okay? And then for every case, you have to take it, you have to put it here, and then you have to decide what is F. Okay, is that right? So number one, given a circuit, okay, can you give me the truth table? Yes, we can do that easily, right? I want to do the same thing, but in sequential circuits. So I will give you a sequential circuit. I want you to give me a table, but the table will be somehow different because the case is it's different case. Okay. Also, as I told you before, the truth table, or we can use diagrams, timing diagrams, and that's what we did in mini labs. So, for example, X is going to become something like that, or this is actually Z. Y is going to become something like that. Z is going to become something like that. Okay, and then this is F, a timing diagram. Okay, so again. That's what I will do right now. Okay, so similar to what we did before. If I give you a combinational circuit, you can make a truth table and also you can make the timing diagram. And the truth table and the timing diagram is the meaning of analyze. So I can know how this circuit works just from the truth table or from the timing diagram. I know how it works. Okay. Or what is the relay? In other words, what do you mean by how it works? In other words, what is the relation between output and inputs? What is the relation? Okay. What output I will get for each input? Okay. So truth table and timing diagram can do it. I want to do exactly the same thing, but this time I will give you a sequential circuit and you will give me something like this too. Okay. But okay, guys. Very important to make an analogy here. Just to understand what I will do. This is the second, so the next section here. Yeah. So here in this section, I'm gonna teach how can you analyze sequential circuit. In the last two sections here, I'm gonna explain how can you design logic circuits. Okay. Sorry, sequential circuit. So here let's see what will be similar and what will be different from a combinational circuit. So as you see here before, number one, I give you a circuit, something like that. And the circuit should have, any circuit should have flip-flops, also should have output and should have input, output and input and flip-flops, okay? Anyway, so I will give you a sequential circuit, and then you need to create a table, but this time I'm gonna call it a state table, and it has a little bit different format from the truth table. So this one is similar to the truth table, but here this time we call it a state table. I will give you more details. But I just want you to understand what I will do here for state table is similar, state table here is similar to the truth table. Okay? But it will be a little bit different. Okay, as I am telling you. Same thing here. Here we have what we call a state diagram. So this state diagram, as you see here, is similar to the timing diagram there. But here we call it a state diagram. Is that okay? Anyway, so that's what I'm going to teach right now. So what I'm going to, again, what I'm going to teach, given a sequential circuit, how can you make the state table? How can you make the state diagram? And what I'm doing from the state table, state diagram, you can know how the circuit works. The relation between input and out. And this is exactly similar to what we did before, but before we call it truth table and timing diagram. Is that okay, guys? Let me give, it's not difficult. The circuit looks big, but it's not difficult. I will show you how it works. Okay, guys? Okay. Let's start with this example here. In this example here, guys, as you see, we have two flip-flop, as you see here, D flip-flop, we have two of them. As I told you before, the two groups are connected together, and this is actually what we do, even if you have a big circuit. So if you have a big circuit, all of them are using the same flow. Otherwise, they are not very synchronized. Okay, so that's why you can see all of them have the same flow this way. And then you can see we have one input here, I'm going to call it X. We have one output here, we call it Y. Is that okay? How many states you can have here? How many states? 4 states. Okay, so this one is 0, 0. This one is state. Okay, 0 or 1, 0 is another state. 1, 0 is another state. 1, 1. So we can have up to four states. Okay, so the number of states equal to the number of 2 to the power of number of flip-flops. Okay? That's okay. So all what we have to do, guys, is number one, I need to create the state table. Once you create the state table, it's very easy to make the state diagram. So once you have the state table, it's very easy to draw. I will teach you. This is the most important thing. Once you create the state table, it's very easy to draw this diagram from this table. I will teach you how. But the first step is we need to create this. We need to make the state table. A state table is similar to the truth table. You have input in the truth table, you have input and output. But this time I have input, I have a state and have output. This is the main difference. So here, as you see, guys, here, we have input, and the input here is actually A and B. By the way, here in a step, here A is actually Q here here. Because I can use Q because I have two flip-flops. If I say Q, so which one? Okay, just to differentiate between them. This is flip-flop A and this is flip-flop A. And the Q here, I'm going to call it A, Q here, I'm going to call it B. So this is similar to Q before, but because I have two, I need to differentiate between them. Okay, so similar to what we had before, in the truth table, when you create the truth table, I have inputs and I have outputs. Okay, this way. It's almost the same thing. So the first thing we have to do, guys, here, this is the input here. But the input here should include the states A, B, and X. You got what I'm saying? So forget this one now. Okay. So the first thing we have to do is we have here our inputs. Inputs is actually the states and the input we have. Okay, these are similar to our inputs we had before. So in this case, you can think like we have 3 inputs. Why? Because the output does not only depend on the input, but only the input, but also the states. Okay, so here, so I have 2 flip-flops. That's why I have 2 states here, A and B. A is the Q of this flip-flop. B is the Q of this flip-flop, and then 1 input X. Is that okay? So this is similar to what we did before. We have it's like we have 3 inputs. It is like we have 3 inputs. Okay. So in truth table, when you have 3 inputs, and then what you did after that, I have to put all possible cases. That's exactly what I do right now. Okay. So here I'm gonna put the states. You have two states, A, you have two flip-flop A and B, and then we have input X. After that, I'm gonna put all possible cases, which are, as you see here, 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 1, 0, 1. So now I have all possible cases for the input X and for the state A and B. You got, so here until now nothing is new, similar to what did before. Similar to what we did before. The only difference is I'm gonna consider A and B like an input, okay? So now I have 3 inputs, one D input, and then we have 2 for the states, and then I'm gonna put all possible cases. Is that okay? It's similar to what we did before. Now the question is, okay, so this looks easy. Once you create this one, how can you create the output here? Okay. First, the output here will be, number 1, the real output we have here, Y. Number 2, the new states. What are the new states? Okay. So I need to fill up this one. That means, in other words, look here, guys. That means if I'm in state 0, 0, if I'm in state 0, 0, and the input is 0, the next state is going to be 0, 0, and the output is 0. But if I'm in state 0, 0, and the input is, so X is 1, so the next state is going to become state number 1, and state the output is 0. You got what I'm saying? But anyway, forget what I said. So now the question is, number 1, it's very easy. Number 1, here you have to put the 2 flip-flops you have, or the 2 states. If you have 3, you have to put 3. If you have 1, you have to put 1. So for every flip-flop, you have to make 4. Okay. Number 2, if you have 1 input, I'm gonna make 1 column for the input. Sometimes you have 2 inputs. Sometimes it depends. Okay. So whatever inputs you have, whatever states you have, so I'm gonna put them here, and then I'm gonna put all possible cases. Okay. And for the output, I need to calculate what is, if this is the input, what is the value of Y? And what is the next state? I need to calculate these ones. Okay. Is that difficult to make this part before I explain? This part is easy, right? So before I explain the second part here. So giving this input, how can you calculate these ones? Okay. The way you have, is that okay before I continue? Okay. So now, very easy. The way you have to calculate these ones here, guys, this part here, I need to find 3 equations. I need to find 1 equation for the new A. I need to find 1 equation for the new B. I need to find 1 equation for Y. Once you have the equation, you can just plug in what is the value, and then whatever the equation gives to you, just write it here. So I need to find 3 equations. Okay? And for every input, what is the equation? There is the output of the equation, there is your output. That's it. Okay? So how can you get the equations? Okay. The way you need to get the equation, number 1, I need to calculate here, because this one, I need to calculate what's the logic you have here in the input of the D flip-flop. So you need to get what is the input here. So based on what we have here, this is A, right? This is X, right? This is A and X. This one is X, but this one is B. Okay? So what I have here, this one is actually A and X, or X and B has to be here. Is that okay? So the input of the flip-flop is AX or XB. This is the input. Okay? This is for the current state. And because you know the characteristic equation of the D flip-flop, the new Q of T plus 1 equal to D. So the output is the new value for A is actually equal to the same value, same like this one. Because this is the characteristic equation. Okay? So number one, you need to calculate what is the input here of the flip-flop. Number 2, you have to use the characteristic equation of the flip-flop to calculate the output. And here, because the characteristic equation is easy, the output equal to the input. It's very easy, right? So I can see here the first equation. I can write it here, guys. Look here. A of T plus 1. The new value for A is equal A at T, X at T, okay? X at T, B at T. So the new value for A is actually equal to the old value of A, and X or X and B. Make sense? So number one, you need to calculate what is the input of the flip-flop, and then after that you need to plug in the characteristic equation. And here, because the characteristic equation is just easy, straightforward, Q is equal to G. Just Q is equal to G. Okay? And because always this one in time T plus 1, and always what we have here at time T, that's why usually we just cancel this T. Because we already know it's all the time. Whatever here at here is this is the new value for A or for this flip-flop, and then this one was at the old value or the value at T. That's why sometimes we just delete T. Okay, guys? So this is the first equation. Okay, so using this equation, I can simply fill up this column. Okay, how? Yeah, because this is equation has AX, so all what you have to do, A and X or X and B. You can understand? So for every input here, you have to plug in this equation and then calculate what the values you have here. Okay. So this is the first equation you can get. I will repeat again for B. Let's look how can we do it for B. How can we do it? Again, all what you have to do is I need to get what is the input here. Okay. Here we have A and here X, and this one actually is A prime X. So this one A prime and X. Okay. So now the equation for B is actually B at time T plus 1 equal to A prime X. And again, I don't need to say what is the time, because usually this part at time T. Okay. So here the new value for B is equal to A prime X. So you need to get the input here, and then you have to plug in the characteristic equation. And here it's very easy because Q is equal to G. It's easy. So whatever you get at G is actually equal to Q. Okay, because this is a characteristic equation is. This is not the case for GK flip-flop or for T flip-flop. But this is the general idea. The general idea, number one, you need to calculate the input. What is the value at the input? You need to plug in the characteristic equation, you will get the new value for P. Okay? That's it. So here, so this equation should help me to calculate this column here. So this column actually A prime X. Okay, A prime here, sorry. Let's calculate it. Okay, so here A prime is 1, X is 0. So that's why the output is 0. 1 and 0 is 0. Let's look at next one here. A prime is 1, X is 1. 1 and 1, then we get 1. You get it? So now here, A prime is 1. This one is 1. But this one is 0. Okay, so I will have 0 here. Okay? We have 0 here. Don't think about it. So it's going to be 0. What 0 here? Don't think about it. It's 0. Okay, but let's look at this one here. This one here is 1. But here, A prime is 1. So 1 and 1 should give you 1. You got what I'm saying? So what I'm saying here, guys, once you have this equation, I'm gonna plug in A, I'm gonna plug in X in this equation, I will get B. Is that okay? Okay, good. Okay, what is left is Y. So Y here, guys, same thing. So here, this one is coming from B, right? So this is B. This one is coming from A. So this is A. Okay? This one is coming X, and so this is X prime. So now Y is actually B or A, is that right? B or A and X prime. Is that okay? Okay. There is something tricky here. You need to think a little bit about it. Okay. Here, once the input change, Y is going to change immediately, not at the clock. Okay. Y is going to change whatever values you have here, it's going to change immediately. Okay. That's why here this Y is actually function. It's actually in T. So here Y at time T should equal B at time T or A at time T and X prime. Okay. Anyway, this is not going to impact anything, but I just want you to understand In case of Y, I'm gonna use T, okay? But in case of A and B, I'm gonna use T plus 1, because this is gonna need for a clock, okay? To change the output here, I need a clock. But this one can change immediately. Once it changes, this one is gonna change immediately. But anyway, so again, the equation I have is, it's not gonna change anything. So the equation I have here is A or B, and X. Okay, so all what I have to do, similar to what I did before, I have here A, I have B, I have X. So for every input, I need to calculate, I'm gonna use this equation to calculate the output. Okay. Okay, so let me summarize. I have 4 examples here. In the 4 examples, I'm gonna follow exactly the same steps. I will follow the same steps in all the examples. But let me tell you, summarize what I said so far. So what I said so far, guys, if I give you a circuit like this one, okay? So now the table should have 2 parts. You have to put here the states. We have 2 states here, A and B. So I'm gonna put here A and B. Also, I have here X. I'm gonna put X. Is that okay? The input and the states. Okay? So that means if you have 4 flip-flops, so I have to put 4. If I have 2 inputs, I have to put inputs. Whatever inputs you have, whatever the flip-flops you have to put them in this one. This is number 1. Number 2, you have to put all possible cases. This is number 2. Is that okay? Number 3, I need to find what is the new A, what is the new B, and what is the Y, the output Y. So here, the state have to be the input and also the output. So here, in the input, I'm gonna put the state and also input. In the output, I'm gonna put the output and also the state, because the state are gonna change. Okay? For every input, the state may change. Okay, so I need to calculate the new state. Okay? So here, to calculate these ones here, I need to find equation for A, equation for B, equation for Y. This equation should be function in A, B, and X. Okay? To do that, number 1, I need to find what is the value here for input, the input of the flip-flop. Okay, and then once you find the value here at the input of the flip-flop, you are gonna plug into the characteristic equation to get the output. Okay, so I will follow the same sequence. I will follow the same thing when I go for. So now I created the state table. Okay, to select 1 minute. Now, after that, once you create a state table, how can you create the state diagram out of the state table? Okay. So let's see. I'm explaining here in details. So number 1 here, guys, you know already because I have 2 flip-flops, so I should have four states. So as you see here, I should have 4 states. State 0, 0. When the 2 flip-flops are 0, 0, I have a state 1, 0. When this flip-flop is 1, when this flip-flop is 0, 1, 1. When the flip-flops are 1, 1, 0, 1. So the first thing you have to do, I have to make circuits. I have to make 4 circuits this way. I have to make 4 circuits this way. 1 circuit for every state. Because I have two flip-flops, I should have 4 states. Is that okay? This is the 4 cases I have. Now, how can we make these transitions? This transition here. I can make this transition just from here. Okay? Let's see how it works. For example, here I'm using colors here. For example, if you look at the first one here, guys, if I'm in a state in 0, 0, and X is 1, so the next state is 0, 0, okay, and Y is 0. How I can draw this one here? Look here, guys. If I'm in a state in 0, 0, okay, so the next state is 0, 0. So I have to be this way. So we have 0, 0, next state will be 0, 0. This is if the input here is 0 and the output will be 0. Again, let's look another one. So here, if I'm in state 0, 0 and X is 1, so your next state is actually 0, 1. And that's what happened here. If I'm in 0, 0, okay, and input is 1, so this is the input here. We put input and then flash out, okay? The input is 1, so I have to move to this state, 0, 1. And the output is 0, okay? you have to continue this way. For example, if you take, let's take, here I use colors to make it easy for you to understand how to move it. So if I take this one, if I'm in state 0, 1, input is 0, so I have to put it 0, 0. So here, if I am in 0, 1, okay, 0, 1, I have to go to state 0, 0. That's why I have to go here. This is when the input is 0, and in this case, the output is 1. Okay? Same thing here. If I'm in 0, 0, okay? Next state is 1, 1. That's why I'm getting this right here. If I'm 0, 1, next state is 1, 1. This should happen when the input is 1, the output is 0. So nothing I want to say here, guys, before nothing. That's what I said before about sequential circuit. Look here. If I'm in state in 0, 0, 1, if the input is 0, I'm gonna get 1. And then I'm gonna move to this state. But if the input is 1, I'm gonna get 0. So the output, look here, the output is 1, the output is 0. So the output does not only depend on the input, but also depend on the state, which state you are in. Yeah. So here, if I'm in state 0, 1 here, and then here, input was 0, okay? So I'm gonna get 1, or the input is 1, I'm gonna get 0. Okay. So here, so I'm gonna move to different states. Anyway, so I will teach it next time as well. Okay?
Next time on to